Types of rapid prototyping. There are three types of rapid prototyping techniques based on the techniques: liquid based method, solid based method, powder based method. The liquid based rapid prototyping systems have the initial form of its materials in the liquid state. Through a process commonly known as curing, the liquid is converted into the solid state. For example, stereolithographic process. A solid based method, except for powder, solid based rapid prototyping systems are meant to encompass all form of material in the solid state. In this context, the solid form can include the safe in the form of wire, roll, laminates, and pellets. For example, fused deposition modeling process and laminated object manufacturing process. Then powder-based method, in a strict sense, the powder is by and large in the solid state. However, it is intentionally created as a category outside the solid-based rapid prototyping systems to mean powder in grain-like form. For example, sintering process, selective laser sintering, selective laser melting process. So these are the comparison in between these three stages of RP system. The first one is liquid state RP systems. In this process, these are the methods based on these liquid methods: stereolithography process, solid based curing, fused deposition modeling, and ballistics particle manufacturing. So these four processes, this layer creation technique is liquid layer curing, and milling. For the fused deposition modeling process, the layer creation technique is extrusion of melted polymer. For the ballistics particle manufacturing, the layer creation techniques is droplet deposition. So like this, the phase change type is for the stereolithography process is the photopolymerization. For the solid based curing, it is also photopolymerization. For FDM method, the phase change type is solidification by cooling. For ballistic particle manufacturing, also solidification by cooling. Here, the stereolithographic process, the materials are used for the processes for photopolymer, that is acrylates, epoxies, colorable resins, and filled resins. For the solid based curing process, the photopolymers is used as the raw material. For the FDM process, the polymers like ABS, that is acrylonitrile butadiene styrene, polyacrylate, and PLA plus, wax, metals, and ceramics with binders are used for the FDM method. For ballistics particle manufacturing process, the polymers and wax are used as the raw materials. In the powder paste method, there are two methods. One is the three-dimensional printing, that is 3D printing. Another one is the selective laser sintering. So these techniques, the layer creation technique is layer of powder and binder droplet deposition. For the SLS process, the layer of powders. Then phase change type for these two methods are no phase change. Here, for three-dimensional printing, there is no phase change of material. For SLS, laser driven sintering, melting, and solidification. The laser source is used to melt the powders and then solidified. So ceramic, polymer, and metal powders with binders are used as the raw material for the 3D printer, as well as the polymers, metals with binder, metals, ceramics with sand and binder are used as the raw materials for the selective laser sintering process. The last one method is the solid based method, the laminated object manufacturing, that is LOM process. The layer creation technique is deposition of sheet materials. The phase change type, here also there is no phase change because here the use of raw material is the solid state. Solid sheet is used as a raw materials. The materials, papers and polymers. So let us discuss the advantages and disadvantages of the first method is a stereolithography process. The advantages are achieving the accuracy in industries, capable of high detail and thin walls, good surface finish, high part complexity. And disadvantages are requires post curing, some warpage, shrinkage, and curl due to the phase change, limited materials, support structures always needed, removal of support structure can be difficult. For the FDM process, advantages: durable parts can be made, minimal wastage, easily handling, material changeover and support removal, no post curing, office environment friendly, low end and economical machine, easy material changeover and support removal, variety of materials, and also it has some disadvantages: longer to build, low accuracy compared to the stereolithography process, not good for small features, details and the thin walls, surface finish is rough, support design, integration and removal is difficult, weak eject axis and slow on large and dense parts, support requires on some materials and geometries. These are the advantages and disadvantages of the laminated object manufacturing process. Advantages are a wide range of materials, fast build time, high accuracy, durability and high part complexity, requires post curing, overheated roller may damage the seat, limited materials, that is photopolymers, and support structures always needed. These are the disadvantages of laminated object manufacturing process. And the advantages of selective laser centering process: no need of support structures, no post curing required, variety and flexibility of materials. The main advantages is that the fabricator prototypes are porous, typically 60% of the density of model parts, thus impairing their strength and surface finish, fast build times. And the disadvantages are rough surface finish, additional powder may get hardened while solidification along the borderline, mechanical properties below those achieved in injection moldings process for same materials, and mainly build variables, complex operations, material changeover difficult compared to the fused deposition modeling and stereolithographic process. So in the next video series, we will discuss about the rapid tooling one by one. Thank you for listening.